All right. Awesome. Well, thanks for hanging around to the last session, guys. My name is John Taubensee. I'm a program manager on the Azure messaging team. Today I'm accompanied by Kent Weir, a Microsoft Azure MVP and a senior enterprise architect for TransAlta. Our session today is about real-world messaging. So we're hoping to give you guys a couple more samples than just a Contoso or Fabricam idea to go home with. So with that, I want to cover a little bit of business before I hand things over to Kent, and then we'll have plenty of time at the end for questions as well. So first off, for those of you who aren't familiar with messaging, I want to go over some of the reasons of why you would use it. The first one is to protect systems from one another. The example that we like to give when talking about messaging is an e-commerce website. Imagine you have web front ends that accept orders, and then you have back ends that process those orders. If you use a service bus in the middle, you can help insulate those systems from one another. So for instance, if your back ends go down that are processing those messages, you can still continue to accept orders without any problems. That allows you to generally increase overall availability between your systems as a whole. And it allows you to scale out and not up. So rather than adding CPU horsepower, you add additional instances. And in the example that I just gave, you can scale up either your web front ends or your back-end processors independently of one another. Another great use case for messaging is hybrid, right? So those front ends or back ends could live wherever you want them to. They could be in the cloud, they could be on-premise, it really doesn't matter. And it also allows you to simplify programming models. So essentially you have producers that only have to worry about producing messages and consumers that only have to worry about consuming messages. Oftentimes messaging seems very complex, but in general the principles are very simple surrounding it. So when it comes to messaging, what does Azure actually offer? We really have three offerings, the first of which is messaging. You guys may know it as Service Bus, Queues, and Topics. It's essentially a publish, subscribe, enterprise messaging platform as a service offering with a lot of advanced features like transactions, duplicate detection, scheduling of messages. And for those of you who are familiar with messaging previously, you guys might know MSMQ. It's a very similar offering to that, but done as platform as a service, just as all of our services today. Just out of curiosity, who's played with Queues and Topics before? Who uses them? Awesome. So Service Bus is actually a service that's been around for almost 7 or 8 years now. I want to say it was the 4th service on Azure, so it's been around for quite some time. One of our newer offerings is Event Hubs. How many people use that? So a little bit fewer, certainly not as many as messaging, but it's a relatively newer service. It has a lot of similarities to messaging, to Queues and Topics. It's essentially used for distributed telemetry and logging. And while there's a lot of similarities between it and messaging, one of the key differences is that when you receive a message from an event hub, it isn't removed from that event hub. It can be pulled down again. So this is really useful if you have multiple processing streams, whether that be real-time processing using something like Stream Analytics, or whether that be batch processing using something like Event Hub's Archive that will push those messages automatically out to storage for you. The last service that we have is Relay. Who here uses Relay? All right, so a couple of you. Relay is an interesting service. It allows you to project a public endpoint for on-premise services without using VPN or complex firewall configurations. So essentially, an example I like to use there is if you had an Oracle or a SQL server on-prem that you couldn't move for whatever reason, you can still connect that to the cloud and have a web application front end running in the cloud that utilizes that on-prem resource. So by the numbers, we really like to brag about these. We're certainly very proud of them. In the last week alone, Event Hubs has processed over 3.8 trillion messages. That is certainly a lot, and then across all of our services, we average about 6.3 million 24/7. Messages in general are pretty small, usually around 256 kilobytes. With our premium messaging offering, we do allow message sizes up to 1 megabyte. And with all that said, we have processed over 28 petabytes in the last month alone. So that's an awful lot of messages. While those numbers are certainly intriguing on their own, what I'm personally most proud of is the fact that we've done that with over 4.9 success rate and an average send latency to event hubs of 50 milliseconds. So what's so special about the cloud? First off, it's pay-as-you-go. There's no licensing, no hardware cost, zero setup effort. These are probably things you guys have heard in other sessions this week. You only pay for what you use. There's no commitment, and it's generally speaking very cheap. It's scalable and elastic, so it grows when you need to. Here's an example of what our portal looks like for event hubs. If you need more throughput units, just simply drag the slider up. Simplified management, easy to use web interface, infrastructure as code using ARM templates, essentially a JSON representation of what your infrastructure is. Makes it very easy to deploy new environments, to add other environments, and then also to keep that JSON template file in source control. So you have a history of it. We guarantee 3 nines SLA on all of our services. These are things that a lot of businesses find that it's harder to achieve on their own. Without experts in-house, thinking of running your own networking stack, hardware, you name it. These are all things that are done by us. So when there's a problem, you get to call us. Again, probably something you guys have heard of, but just for sake of thoroughness, traditionally speaking, when you guys had on-premise systems, you were responsible for everything, right? So application, OS, hardware, networking, even physical security to the building itself. With IaaS, we remove a lot of that. You still own the OS though. And owning the OS still comes with its challenges because you have to patch that OS. You have to patch any applications running on top of that OS. And in order to coordinate that, downtime can be difficult. But with a PaaS solution, we do all that for you. So with all of our messaging solutions, we have partitions, and whenever we do an upgrade, we never take down, or we always leave up at least one partition so something's accessible for you guys. So what do people actually do with messaging? Here's a list of industries where you'll find messaging. There's not a lot that's not on there. What we find today is that it's not so much about the industry anymore that you're in. It's more about what kind of a cloud architecture do you want to have. So when you're trying to develop highly reliable systems, highly available systems, messaging is usually a key component for that. Some of the systems that people develop on top of this, order processing, as we mentioned, logging and telemetry, connected and IoT devices, and then notification and event-driven systems. We see all sorts of things, but this is a lot of the core of that. So without further ado, I'll turn things over to Kent and let him show you guys what he does with messaging.
Okay. Thanks, John. Yeah, it's on. Okay, here we go. So thanks, John. So my name's Kent Weir. I'm a Azure MVP, and I'm also a senior enterprise architect for a company called TransAlta. So TransAlta is a multinational energy company with operations in Canada, United States, and Australia. We focus on power generation, energy trading, and wholesale marketing as our 2 core business lines. We've been doing power generations for over 100 years in the province of Alberta in Canada. And our annual revenue is approximately 3 billion Canadian with around 9 billion in assets. So here's the environments in which we operate in, United States, Canada, and Australia, as I mentioned. In terms of our fuel types, or the type of power that we generate, we do so using coal, hydro, gas, wind, and solar. So before I dive too far into the cloud messaging, I thought it would be useful to take a step back and talk about our journey to the cloud, as this is something that's been front and center for the last, let's say, 14 to 18 months for us. So we're on this journey to the cloud, and it's really a result of the realization that what we did yesterday will not be sufficient for tomorrow. So like many organizations, IT has historically been involved in provisioning infrastructure, installing applications, doing a little bit of custom development, and really just supporting the underlying services of the business. However, driven by regulatory and economic uncertainty in our space, largely related to a new government that has introduced new goals for coal, and with coal representing approximately 50% of our output, we know that we need to transform as a business. There is a future, it's just uncertain. We just don't know where that dial is going to end up. And as a result, we need to be as flexible and agile as possible. And we see the cloud as a lever that we can pull as an IT organization and a broader organization in order to help transform the business as they go out and compete in new markets. One thing that we've been really focusing on is avoiding large-scale capital spend. So like many other customers, you probably have these life cycles where you renew your core infrastructure every 3 to 5 years perhaps, and it's usually a big spend, and then it's something that you pay your maintenance yearly, and then you have to do it 3 to 5 years later. So we're in a cycle where that's not going to work for us anymore. The business needs that money to grow, not to basically pour concrete into our data center. So that's another kind of key pillar for us as we move forward. And there's certainly no reduced expectations as we enter a tougher economic climate. In fact, I would say the demands are even greater, where we're asked to do more with less. And once again, we see cloud as an opportunity for us. We've also been really focused as an organization on lean enterprise principles, which really focuses on your value chains. And for us, we really have 2 value chains. Number 1, we generate power. Number 2, we trade and sell power. So as an IT organization, we find ourselves looking in the mirror trying to determine when we're performing an activity, which of those value chains are we actually going after? And this was another thing where, yes, providing infrastructure is part of that responsibility we have as an IT shop, but we want to make sure what we're doing is as cheap and as efficient as possible. And lastly, our outcome needs to be more capabilities for less. And I think cloud has really helped us in this area where we're building applications that we couldn't build 3 to 5 years ago. It truly is mind-blowing for us. So what are we working on? So our goal, in order to reduce that large-scale capital infrastructure spend, is to have 0 data center by 2019. So this includes 6 data centers located throughout the world. We've already started by migrating virtual machines to infrastructure as a service on Azure. So this would include predominantly dev test workloads, but we do have some production workloads. We've also been on a disaster recovery project where we're actually protecting and replicating our SAP and our trading environments. So if people tell you it can't be done, I'm telling you it can. But this has been really key for us. Historically, once again, we'd buy this converged infrastructure on premise. We would then buy a copy of the converged infrastructure. It would sit idle in another remote data center, and we're paying a lot of money for that, maintenance and renewal. So we see this cloud as an opportunity for us to pay for some protection from an agent perspective, and then we need to pay for storage. And basically we can then light these things up, do tests on demand whenever required, but using our capital really efficiently. We've also become more of a data-focused organization, and really Power BI has helped us with this. We started working with our local Microsoft subsidiary, doing a lot of immersion sessions, getting our business users trained on the tool, and then growing up with the tool and moving into some of those enterprise use cases. Another area that we've been focusing on is adopting platform as a service offerings. And really, the driver here is once again focusing on activities that add to those value chains. So we've introduced the Azure API Management, Azure App Service, both web and Azure SQL. We're using Logic Apps. We've started to go down that path with the integration platform as a service offering. We are using Azure Stream Analytics, and underpinning all of this is cloud messaging. So we are using Event Hubs, we're using Service Bus queues and topics, and we're also using Relay. So as part of this presentation, I'll be able to cover 3 use cases, each covering each of these Service Bus technologies. So the 3 use cases we're going to focus on are 1, an industrial IoT telemetry solution using Event Hubs. Next, we'll talk about energy trading pricing using Service Bus topics. And lastly, we'll talk about exposing SAP master data using the Service Bus Relay. So with this project, it's something that we just wrapped up a few months ago. And what prompted the project was that we had a vendor upgrade that was occurring within our data collection for one of our fuel types. So you can imagine in an industrial setting, you have SCADA networks, you have data collection, you've got something called a historian, which you kind of can think of as a large database. You're going to track all of the output or the telemetry of your different pieces of equipment. Now, in our case, we use this to monitor our equipment. We'll run analysis on the equipment. We'll work it into our preventative maintenance programs. We also need to use this data for billing. If we're producing power, we need to actually bill for that power. So that's another area that we use this data for. And then also compliance and reporting. So it is a deregulated environment, but we do have commitments to the regulator to ensure that we're doing what we're saying we're doing, and we're doing it in a sustainable and safe way. So we're using all of this data for those functions. Lastly, as part of this project, we wanted to include the ability to provide some greater support, some greater insight for our field IT and operational support teams, and we can do that through things like Power BI dashboards. Another key pillar for this project was the flexibility to evolve. We had some core requirements that said, okay, get the data from here to there. But really, as an IT group, we want to actually provide value add. We want to actually enable the business, help them evolve. And using the different building blocks inside of Azure allows us to do that. So what were our timelines? So we started off with a POC in January. And it was, initially there were some concerns about it. It was like, oh, you're going to be moving some pretty important data through the cloud. What are the security concerns? Are there constraints? How reliable is this thing? How much does it cost? Things of that nature. So we were able to turn around a POC very quickly, like in hours, maybe a day or two. We then met with the business and functionally showed them, yeah, we know what we're doing here. We've done this before. We know what we're doing. Then we did talk a little bit about security. We talked about the cost, the projected cost, and suddenly our business was really interested. They were good. But as I mentioned previously, we have a partner that's doing the data collection for this particular fuel type, so we needed to work with them to get them on board to make sure that they were interested in this. Alternatively, a solution that was proposed was to just use their flavor of a historian, which would include more than a $200,000 license fee for us. We didn't want to go down that path. So we did have a collaborative set of architecture reviews with them. It surprisingly went well. And we got into some contract negotiations, and we actually started the build in February. We completed our testing in March, and in April we went with a parallel go live. So we had the legacy solution, which was no longer on vendor support, running in parallel with our new cloud solution. So we could easily compare, performance, reliability, data integrity, all of those types of things. In June, we decommissioned the legacy solution, and we've been running exclusively on the cloud messaging platform since then. And just to give you a sense of volume, while it does, it's nowhere near as impressive as some of John's numbers, we have processed 147 million events through this solution. And so with that, we feel it is battle tested, it is robust, and wouldn't be on stage if it wasn't. So here's a sense of the architecture. On the left-hand side, maybe I'll just jump over here. So this represents our partner environment, where we have the firewall. And here's where the two historians exist, and we have a publisher. And that publisher is going to publish data using AMQP to our Service Bus Event Hub. Now, in terms of the type of data or the classification of data, we're moving 1-minute data, 15-minute data, 60-minute data, and also what we call raw, which is real-time data. So if we have an alarm coming from the SCADA system, that'll actually propagate through our cloud messaging solution in real time. Now, behind Event Hubs, we're going to have Azure Stream Analytics. So the purpose of Stream Analytics is to do some level of aggregation, calculations, and some routing for us. Now, routing in the sense that we want to take some information and publish it to Power BI, so we've got some real-time visibility into the state of our environment or our plants. The second path is it's going to route the information to Service Bus, a Service Bus topic. Now, we still need to get this information into our environment so that we can actually populate our historian, our existing legacy historian solution. So we're using BizTalk in order to do that. So we're a long-term BizTalk customer. There's a Service Bus messaging adapter. It was pretty easy for us to basically wire that up and pull those messages down and feed our historian. Now, secondly, there's this normal scenario, which I recently learned, was that SCADA systems aren't always reliable, even though they say they are. So you might have periods or windows where data isn't being collected. It could be the device has failed, it has some sort of issue. There could be some network connectivity issues. And as a result, you'll have a missing period where you may not be collecting data for a device. So there's a process called the backfill process where you can actually request all of those missing reads once they become available once again. So we built an outbound interface from BizTalk to the Service Bus topic where we would basically say, here's our tag name, here's the time frame that we would like the tags for, and then our partner will be able to dequeue this message from the topic, retrieve the messages from the historian, and then publish them over the same AMQP channel to our event hub. We also have some tags where we have some special, rules or timing around scheduling. So we've built a scheduling process where we'll basically execute these backfill requests automatically throughout the day based upon some specific business rules. Now, lastly, one of the concerns that our leadership brought up was, okay, well, this is in the cloud. We don't see the servers. We can't kind of kick them or turn them on or turn them sideways. How do we know this thing's working? And while Azure does have, Azure alerts, and I see that the story is evolving with Azure monitoring, which is great to see, but we also took it upon us to send what we call synthetic transactions or heartbeats through our solution. So since we are a BizTalk customer, we do use a third-party monitoring tool called BizTalk 360, which has the ability to send a web endpoint test. So every minute, what it'll do is actually sends a heartbeat message, and it's going to do that using HTTP. And we do wrap our Event Hub credentials behind an API management operation, and we will then publish this heartbeat message onto an Event Hub, and it will flow through the entire solution. So it'll hit our Stream Analytics job, it'll hit our Service Bus topic, and it'll hit BizTalk. And if it doesn't hit BizTalk, then we know that something has failed. We know that the heartbeat hasn't made the full round trip and there's something going on. So we did this kind of as a precautionary thing. We were interested in kind of understanding, make sure we had coverage first as opposed to waiting for something to break and then be like, oh, whoops. So, recently it kind of paid for itself in the sense that we had a request come in. They said, oh, we're missing data for 13 minutes from 4:13 to 4:26. Is everything okay with the cloud? And I knew because we hadn't received any of these BizTalk 360 alerts, I felt confident that, yeah, the issue's not on our side. So sure enough, we did our due diligence, proved that we were receiving heartbeats, all of the mechanics of the solution were working, and it did end up that on our partner side, they had some sort of infrastructure hiccup which prevented those messages from actually being sent across. So it is important to still holistically test your solutions, but we do feel that we've got some good coverage with this. So I'm going to show you a demo right now. I can't log into our SCADA environment and show you all of the bells and whistles, but what I've done is I've basically broken out our scenario into some digestible components that I can demonstrate for you. So I have a plant telemetry simulator here, and what I'm doing here is I'm taking a series of 10 different tags. So this is a name of a tag. It's a very ugly, number 0990F1ZA. TA01. And we're also going to include some other information like the timestamp it was published, the actual value, and a quality indicating was the read successful or bad or good. We're going to take a batch of these 10 tags and we're going to publish it every second. And we're going to publish that to our Event Hub. And then what we're going to have Stream Analytics do is Stream Analytics is then going to take that 1 second data, aggregate it, and actually put out one value. It's going to give us a 1 minute average for that specific tag. Because the reality when you're dealing with SCADA systems is you don't want millisecond data, at least not most of the times, right? You can't actually consume it as an end user. So you need some level of aggregation. We're going to use Stream Analytics to do that. We're also going to use Stream Analytics to enrich this data, where we're going to take a real-time data feed, we're going to take a static data feed, we're going to mash them together and actually provide some additional insight. And we can then display this insight inside of Power BI. So here's Power BI. Here's kind of our ticker tape. Now, you'll notice a few things. We've got some plants that don't belong to us. I've done that for the purpose of the demo. But we've got some, I guess, user-friendly names here. So we've got places like Atlanta and Charlotte, New York, Toronto, and Phoenix. And then what we can see is that all of this data is being collected in real time and published to the actual dashboard. Now you're going to see a drop here, and the reason there's a drop is because I had stopped the simulator as we were walking from the prep room to this room, so that's why you're going to see the drop. But you can actually see as we trend across this, these are the actual values. So we've got Atlanta that was at 119.17 at 10:39 Mountain Time, which would have been 12:39 local time. And we can then go across and take a look, and while it's kind of neat and interesting to see this real-time data flowing, the insight isn't actionable. Like, we can't actually do anything with this. Like, I don't know if New York at 33.98 is actually a good value. Should the plant manager be rewarded or fired? I don't know. So we have to find that out. So what we can now do is as a result of using some of that reference data, we can now actually add some insights, some actionable insights to this data. So I've now plotted all of these plants that we're going to talk about today on a map. So we've got Phoenix and Toronto, New York, Charlotte, and Atlanta. And I can actually click on each of the different plants, and then we're going to see on the right-hand side, basically the green light, red light show. So in this case, we see that the Toronto plant is actually outperforming its current expected value. So as a result, our card is now green. But if we go ahead and take a look at New York, we're going to find it's not the same situation. So we've got basically our expected output value, which is 50 up here, and we've got our current output, which is averaging around 34. So as a result, this person's probably not getting a bonus, and there's a reason now to actually drill into this plant to see what's going on, why are we not performing at our expected values. Now another thing, and this is more of a fun thing, but our business users got a kick out of it, is that everyone interprets data differently. Some people are very visual, some people want to see tables, some want to see a specific type of chart. But here's what we like to call plants as fish, where we can actually overlay and see what a plant is actually performing at. So the Toronto plant is 125, it's the bigger fish, and in this case, although I'm sure people from New York would never admit it, but New York is actually the little fish, where it's only 34 megawatts. So once again, that's the nice thing about Power BI is you have different visualizations, different ways to interpret and view the data. So that's the first demo, but let's drill down into some of these specific components around the solution. So we've talked a little bit about Stream Analytics. For those that may not be familiar with it, I like to call it a complex event processor, and it does really well with high-speed ingestion. So when you think about what Event Hubs does, it's a good pairing for it. As data is moving through Event Hubs at a fast rate, Stream Analytics is able to latch onto that data and perform some sort of computation around it. But in order to get the data into Stream Analytics, you need to create some inputs. So what we have here is two inputs. We're going to have a data stream, which is coming from our Event Hub. That's our real-time data. And then we're going to have our reference data. In this case, it's going to be a CSV file sitting on blob storage. So the file actually looks very similar to this. Remember I showed you that ugly tag name before? We're going to see that we've got the tag name in the first column, and then we can provide a more user-friendly name. In this case, it's Redmond. I chose not to plot that one. We also have the ability to include lat long, so now we can represent this data geospatially, and that's how we're able to place it on a map. And lastly, we can also provide our expected value. So this is how we're now able to basically take a real-time stream and compare it to what we expect it to do. Now with Stream Analytics, you can also feed these CSV files on a regular cadence, so that if you have your reference data that it may be relatively static, but it does change every day, it changes every hour, you basically can upload it and basically have an automated process that's going to keep it in sync at that sort of cadence. Here's our output. In this case, we're going to have two topics. One we'll talk about in the next demo called the heartbeat topic. We've got another topic called, basically it's our real-time data, which BizTalk in our solution pulls from. And lastly, we have our Power BI historian output. And within this output, here's where we would go ahead and configure our Power BI data set name, our table, we can choose a workspace, and we need to provide some level of authorization. And we're going to talk a little bit more about authorization in our tips and tricks at the end, or lessons learned rather. Now here's where it gets probably the most interesting. So here's our Stream Analytics job, and it's really broken down into two components. The first one is what I like to call a temp table. We're basically going to perform a query, and we're going to store it in what I would call a temp table of tag read aggregation. The next thing we want to do is, because it is a batch, as I mentioned, we've got 10 different tags or 10 different device reads in a batch every second. We want to basically break that down into individual messages. So we can actually do that using this cross-apply get elements function that's part of Stream Analytics. So now we can deal with it at a record by record basis instead of the entire batch. Lastly, we're going to use a feature called the tumbling window, which is one of the more powerful, compelling things about Stream Analytics. Is essentially what it's going to do is look back for 1 minute in this case and provide a calculation, which we're interested in is an average, for the data set on a per device basis for 1 minute. So as I mentioned before, we don't want to send data every second to Power BI. It could never keep up, nor would it give us any additional insight. If we're going to aggregate this over 1 minute, it can still be actionable, yet we're saving on storage. So Stream Analytics does have a few different windows. There's 3 in total. They all have different capabilities, but this is really important where if you think historically how you might solve this problem is you're going to persist this data to some sort of database, and then you have a batch process that looks backwards, after the hour, where this is able to do this in real time without needing any sort of temporary storage. So the top query is basically going to break it apart and get all of our tags on a 1 minute average. The second query is where we're going to merge these two streams. So we essentially can provide a join, what's the equivalent of a database join, between our real-time stream and our reference stream. And we're going to do so using tag name. So as you noticed in that CSV file, we had the ugly tag name. This is why. Then what we're able to do is to create essentially a composite record set that's a combination of our real-time data, including our tag name, our output, our tag value, and our quality, and then merge it with our lat, our long, our friendly plant name, and our expected value. And that's what allows us to basically join these two streams and publish a consolidated data set for Power BI. So that's the first demo. The second demo I want to talk about is called detecting absence of events. So what can happen is that in that scenario where a device stops reporting, but we still have data stream flowing through, BizTalk 360 wouldn't catch that per se, because it could be, operations are all normal. What we can do with a specific tag is actually look for it. And we can do anomaly detection or absence of events detection using a combination of a few different Azure services. So once again, Stream Analytics is going to do some heavy lifting for us. And when it detects that a tag's not actually reporting, it can put a small message onto a Service Bus topic, and then we're going to have Logic Apps, Microsoft's integration platform as a service offering, listening to that specific topic. Once it gets into Logic Apps, we can do whatever we want. In this case, what we want to do is we want to log a ticket into ServiceNow. For those of you who may not know what ServiceNow is, it is a IT service management tool that deals with, say, incidents, change management, CMDBs, configuration items, things of that nature. So we can now create a ticket automatically and put it into ServiceNow, assign it to our field IT operations group so that they can proactively deal with this issue, as opposed to waiting for an end user to complain that their report is out of date. We can actually go ahead and do this ahead of time and actually increase the customer experience or improve the customer experience. We can also use some other connectivity in Logic Apps to send emails, send text notifications, things of that nature. So what I'm going to do is I'm going to go back to our simulator. I'm going to stop the original feed. Let's just clear the status. And now what I'm doing is I'm still sending a batch. The difference is, instead of sending the 10 reads, I'm only going to send 9. So we're going to have one that's essentially missing. Now it's going to take a minute, because that's what our window is, basically for Stream Analytics to detect that this tag is missing. So during this time, I'm just going to flip over to Logic Apps, and I'm going to show you what that workflow looks like. So I'm in the Azure portal. In the base information for an Azure Logic app, I can go ahead and click on Edit, and I'll hit a design surface. So the first connector or card that I'm going to have in my Logic app is the Service Bus topic. And within this connector, I have some configuration, including the underlying connection details, which aren't shown here. But I also can provide the topic name, the name of the subscription, how frequently I want to actually check this topic for new messages. Next, what I'm going to do is I'm going to go ahead and call an Azure function. Now, in this case, we're going to use Azure Functions to do a little bit of pre-processing on our message. When Stream Analytics does create this message, they add a little bit of serialization, metadata that I'm not really interested in, so I'm just going to basically clean it up and get rid of it. After that, there's a series of ServiceNow API calls that I need to make. And I'm going to do so in order to get the ID, the reference ID for my particular username. So that text that we just heard is the result of Stream Analytics detecting an anomaly. So I'm just going to turn this down so it's not too disruptive. Next, I need to get a reference ID for the group that I want to actually assign the ticket to. So these are just sort of prerequisite steps required in order to actually create an incident in ServiceNow. And then here's the call to ServiceNow where I'm able to provide the category. I'm able to provide that reference data for both my username and the operations group that I want to assign it to. I then can also include the short description, including the tag name that failed and the time it failed. Lastly, after I've gone ahead and created the incident, I can go ahead and send an email out indicating that an incident has been created. And I can do something similar with sending the actual the text message and the email. So if we head over to ServiceNow, we're going to see that there's a recently created incident. Now this is going to be in Pacific time, as that's where my instance lives. So if we see 10:07, so I'm assuming it's 1:07 Eastern, we see that we've got a missing tag alert. The caller was myself, and the assignment group was plant operations. So now we can proactively deal with these types of situations, all using cloud technology. So it is one thing where I find we get into the IoT space and it's all about telemetry and big data and things like that. It's also important to think about different off-ramps that you can use in order to connect to on-premise or other systems, other business systems, and do some actions. So we've actually use Service Bus topics in this way as a gateway to talk to some of our other integration platforms. So we're just going to drill down on a couple of the components of this solution. So this is our Stream Analytics query. And what's going to happen here is we want to actually determine whether or not a tag has shown up within a window. So what happens here is through a 61-second window, we're going to look for this tag. If it exists, then we're going to return a 1. If it doesn't exist, we're going to return a 0. We're going to then store these results in this temporary table called tag exists, and then we can perform another subsequent query on that temp table looking for any records where our tag processed equals 0. So when this happened, then a small message was put onto that Service Bus topic. It was dequeued, and then basically the Logic app fired up. So one thing I want to highlight here is that we did recently publish a case study with Microsoft and the Service Bus team on this solution. So feel free to take a look at that, and you'll get some additional context into what we were trying to achieve, what was the outcomes, and just some other details about that particular project. So now I want to jump into our second use case, and this is related to energy trading pricing using Service Bus. Now with energy trading, you obviously are subject to the pricing of different commodities. When you're trading, you also want to understand your exposure in the market. It's something that our senior leadership team is interested on an hourly, if not daily basis. And in order to facilitate this, we do leverage a third party that does a lot of this pricing aggregation. When there's a price change to a price curve that we're interested in, we need to receive a price curve notification. We can then use this price curve notification to go look for further details related to that pricing event so that we can then feed our trading system. So now in this case, we're really interested in decoupling our sender from our receiver. So we are the receiver, our partner is the publisher, and we don't want to have any sort of friction or concrete in between us. We want to have a very decoupled environment for us. We also learned that we need to insulate the publisher from any sort of outages, planned or unplanned, on our side. So that was an important consideration as we were looking at this solution, in order to deal with updates or proactive maintenance if we have to do core router switch upgrades and things of that nature. We also wanted the ability to publish this information into multiple environments. As you can imagine, having a UAT environment that doesn't have up-to-date data probably isn't all that useful. So we use this Service Bus and subscriptions to help with that. And certainly cloud scalability. What happens with these events is, well, there'll be periods of the days where it bursts. And that's where having fixed infrastructure was actually causing some issues. So this is what our previous architecture looked like. We had a synchronous process from our partner to our environment. We had exposed it through an F5, and we had BizTalk sitting on the back end, exposing some web services. We then were integrating between BizTalk and our trading platform, in addition to getting the additional curve details from the trading partner. So you can see this as a series of orchestration that has to happen in order to get all of the details. The issue was that scalability was an issue. As we were working through the project, we did have performance issues in the trading platform. Those would bubble up to BizTalk. BizTalk would then bubble them back up to the publisher. They started to get some concerns with reliability because of what should be happening in milliseconds is now taking seconds or worse. So that was a concern for them. Also, we did have some challenges with the network firewall configuration. F5 is a very good tool, but I don't think it's fair to say it's overly easy. At least it's not for us. And what we didn't realize at the time was you still need to do some outages to your data center. Obviously, we try to prevent them, reduce the amount of them, reduce the impact, but they still happen more often than I would like. So what we ended up coming up with was this solution where we introduced Azure API management to expose some APIs, a web API tier that will then publish this information to Service Bus topics in addition to do some logging. So what's nice about this is now we do have load leveling. We have this elasticity in the cloud that we can deal with bursts. So Azure API management is more than able to deal with our workloads. We can scale out our web API tiers, which we have set to auto scaling, and we do see it from time to time bursting out to an additional node and then contracting back automatically. And then certainly Service Bus itself is able to handle our load elasticity needs. What's interesting is we don't have any sort of downstream performance issues, and if we did, we now have BizTalk that's pulling these messages off a topic, basically at a speed that it can deal with. We can support application upgrades. As you can imagine, a multi-million-dollar energy trading implementation does require some application updates as you move through the project through warranty and even into sustainability. And now we do have the benefit of publishing these events to multiple environments, which is a bonus for us. So from a timeline perspective, we were about a month away from going live with the project, with the old architecture, and basically it got escalated to myself, as I do have the integration team, and there were some concerns about stability and performance. And so we came up with this architecture and said, okay, we feel like this is the right architecture for us, we can do it, here's the related costs. They said, okay, great, but when can you have it done by? And it was like, okay, well, when do you need it by? Okay, 2 weeks. It needs to be in UAT in 2 weeks. So it was one of those things where, okay, do all of the project governance, go through the steering committee, get the approval, And then that was a Thursday, and on Friday I remember sitting, I was just about to have lunch. I'm like, oh, I should really provision this Azure stuff. We should really get on this. So I set it to provision. We're provisioning API management, the web app, the service bus, walk away, go to the cafeteria, grab a sandwich, come back, and the whole environment's there. And that's just the power of the cloud for us. Like, that was really the eye-opening moment for us that says, hey, this is different, this is real, and there's some tangible savings. If we were dealing with other vendors, we wouldn't even be through supply chain and master service agreements, and now we're able to focus on solving the business problem. So from a transaction volume perspective, this is lighter than our other solution, but we have processed over 25 million events through this solution in a very economical and flexible way. And the last scenario I want to talk about is exposing SAP master data using the relay. So we had built an existing architecture a few years ago. We needed to expose some master data from SAP. BizTalk is our on-premise integration platform. We exposed the WCF services. Life was good until the business wanted a new tool, and they wanted it in the cloud. Now all of a sudden we have this same problem where we have this on-premise integration solution that's working today, but now we need to be flexible, we need to be agile. There's probably a bit of a theme here where you've noticed we're not crazy about introducing more network and network load balancers. So we did look at Relay, and we felt that Relay could help us out in this solution. So here's the existing solution. We've got a management of change application, which you kind of think of as like change management that we do in IT. Well, we also need to do that from an engineering and a plant perspective. So if we need to change a piece of equipment, we have to go through some due diligence and a process to manage that. Obviously, if you're going to be replacing an equipment, you want to make sure you're replacing the right piece of equipment. So as a result, we're tracking all of that data in SAP, in addition to plants and units, functional locations, and notifications, and the ability to update an MOC. We then had another application come along a couple months later it was an electronic logbook solution. So when we have operators at plants and there's incidents that occurred, they need to track these incidents for regulatory reasons. Once again, had the same use for all of this SAP master data. So this was our previous solution prior to the new requirements. And the new requirement was an Office 365 app that needed to consume this same set of data. And we had some constraints when we had to find a solution. We couldn't disrupt the existing applications. It would have been nice to say, hey, we're going to do some RESTful APIs and use API management, but it just wasn't going to happen. We couldn't impose that, nor did we want to do a lot of additional work and then kind of have this mixed model. So what we did use is the Service Bus relay. We exposed those relay endpoints through BizTalk and then gave the public endpoint in the cloud with credentials to our other team that was building that application in Office 365. And now they are able to connect and use the same data set, these same interfaces that our on-premise counterparts are using without additional coding. Now, from a timeline perspective, we knew it was possible. We'd done, a bunch of stuff with Relay in the past and kind of were aware of its capabilities, but it was real this time. It wasn't just a POC. So, but we still needed to prove it out. So we spent about 3 hours getting the first interface working, and then the remaining interfaces, we spent about another 8 hours, and we've gone live in production with this one as well. So just some lessons learned that we've discovered as we've been on this journey is to really drive adoption through POCs. Now, historically, POCs may be a bad word, and I think part of it was just the approach, right? Oh, we need to get some infrastructure. Oh, we need to buy some licenses. And what the leadership is usually concerned about is that there's no outcome. There's no tangible outcome. We spend some money, we do some things, takes weeks, and we're no further ahead than before we started. Whereas now, with the cloud technology, we can do a POC, and we can do it very quickly and in a very inexpensive way, and actually have an outcome. And we've actually seen this on multiple occasions, and it's worked well for us. I've also seen, and this is my personal opinion, is that decision makers like the ability to say no. And that's why it's tough to get approval on some of these really large projects, because there's so much at stake. Well, if you break the problem down, have more of an iterative approach to it, give someone a gate before they've spent a whack of money, they're probably going to be more interested and take a little bit more risk than they would historically, because they know they can stop it. They know they can stop it before it gets too late. Another benefit or lessons learned that we found is just framing benefits holistically. So if we look at the industrial IoT scenario we went through, we could have looked at just the price and like, oh, this is the calculator in Azure, this looks great. But we also took a step back and said, what else does this mean? And we're like, oh, we don't have servers we have to patch. Oh, we don't have to worry about Windows operating server upgrades. We have less concerns around DR because now this is a Microsoft problem. We've essentially outsourced that responsibility to them to provide availability for the solution. So this is actually reducing our OpEx costs when the cost itself is actually really attractive to us to begin with. Another lesson is involving security early. So just because you may use one service bus technology doesn't mean you have the green light for all of them. So that's something just to not assume and actually just do that ahead of time in order to avoid any surprises towards the end of your project. Write ASA queries defensively to avoid job failures. So this is an area that continues to evolve and improve. It was just something we ran into before, like around casting. If you wanted to say cast a value and that cast failed, well, your stream would fail. So that's why you'll see a lot of those, like what I call temp tables, where you can go ahead and do a lot of pre-processing on your data set and actually make sure that your data is rock solid before you start to do things like calculations on it. And you can prevent some heartburn because your jobs can basically recover, or you basically would ignore that data set. Don't tie your Power BI accounts to a user. We were still in project mode when this happened, so it was good news, but we had introduced Microsoft multi-factor authentication in Azure when we were going through this. My account was set up in one of these jobs. MFA killed the job. So we've switched that model. We're now using service accounts, using workspaces, so things aren't sticky to a particular account. Decouple the data collection from analytics streams, similar to the point before. Kind of look at what your priority is and then protect the priority. And don't let things that may be not as important interfere with what's really important to you. So for example, data collection for us is job number one because we're supporting all of those other processes like billing. So we keep that one very lean, very protected. And then we have a separate stream that deals with analytics. In the event that that fails, no impact on our core requirement, which is the data collection. Lastly is leverage the Event Hub replay capabilities. So this was an added bonus for us as we went through some testing. So it's always nice to be able to do testing around scenarios and then replay those scenarios if you run into a bug and making sure that it is like for like. Now, historically, you might have to do some staging of the data and backups and restores and things like that, which is a bit of a pain. But with Event Hubs, because the data is persisted in the Event Hub, we actually can just replay that. And the way you do that is through Stream Analytics. When you stop a job and then you go to start it, it's going to ask you, okay, when do you want to start the stream? And you can say, start it now, start it at the beginning, or provide a date time. And you can actually then set that back to exactly where you want it, hit the start button, and you'll essentially replay those events. So in the event you even had a catastrophe in production and there's some downstream issues going on with the system, you could then still replay those events and do it without any sort of code or any custom development, which is great. So in summary, I hope you've gotten this out of from the presentation, but like Service Bus and Event Hubs are key pillars in our hybrid integration strategy. So the way I like to look at things is that Service Bus can provide some insulation to our on-premise assets. So anytime we're doing integration with a third party that's outside our environment, we're trying to use the Service Bus family of technologies. And it really gives us that isolation. We know we have scale, and it also plugs in and works with a lot of our other existing investments, such as BizTalk and API management. We do find it extremely cost effective. I won't mention the comments, but it's like people are giddy when they see the pricing, as opposed to what our traditional costs have been. We do find that it is scalable. We know that we can turn a dial if we need to be able to ingest more data from both an Event Hub's perspective and Stream Analytics. We also know that we have the ability to use premium if that becomes a concern for us as well, if we really need some more dedicated compute behind this. So I guess we'll bring John back on stage.
All right. Can you guys hear me?
Yep.
Awesome. I think it's pretty cool to have Kent up here. It's not so often that we get to really do a deep dive into customer solutions. As I was sitting down there, I jotted a couple things down. And I was curious what your thoughts were, because I think they might be beneficial to everybody. I know you just mentioned something about costs. I was curious if there's any that you could mention specifically, like if you were talking about your first example using Event Hubs. Say, for example, what does Event Hubs cost you guys?
Well, the entire data collection solution, including ASA and the service bus, it's less than $70 Canadian per month.
And so in the second scenario, you also said that was a multi-million-dollar system, right? So what do you, out of curiosity, what do you spend on messaging, so service bus there?
Similarly, it's less than $50. Like I don't know the exact. It's really rounding errors. Is the way it looks for us.
Awesome. So you also mentioned that you had to do a little bit of convincing to get people to get into the cloud mindset. Do you mind going into a little bit more detail about that?
Well, I think it's, as I alluded to, it's if you can't see it, you can't touch it. There's this sense of unknown. And if you don't understand it, you can't see it, then it's hard to kind of wrap your head around it. What we find, though, is that like success breeds success. So once you have a use case and you've been able to prove that use case, that's kind of your license to operate. It's your license to do more projects like that. And we've seen this cascading effect. Like the first service bus project we did was actually that energy trading scenario. So then that became a reference point for us when we went to do the industrial IoT solution. And now that solution is basically allowing us to do our next project, which is focusing on another fuel type in another location where we're going to be doing more industrial IoT work. So I think it is about not starting too big too fast. I think it is you need to grow into it. But I think once you can do it, if you can nail it, then you have the opportunity to do more. And that's what's worked really well for us.
Awesome. What kind of maintenance does this require? Like how many hours do you guys find yourself a month maintaining this solution?
Virtually none. Like the only thing would be when we had to check a few weeks ago on the issue that wasn't an issue, but it just runs. It really does. Like there's nothing for us to really do. Like it just runs. It's reliable. We don't deal with errors. We're not chasing ghosts. It just runs for us.
My next question is, so how hard is it to create a new alert? So you've got that existing system in place. That's pretty cool. How hard is it to add a new one? Say you want an alert for some other event happens, right?
Well, in that case, I think it's just really around. I just showed a subset to keep it simple, but you can actually use a lot of the reference data to actually feed those different tags into a more holistic solution where it can just become configuration. In my example, I really wanted to distill it down to keep it very simple, but it really becomes configuration for us.
Okay. And then is there anything else you guys are planning in the immediate future?
Well, I think the big thing is our next project where we're going to have even more tags flowing through our system. So we've got around 1,000 tags in our kind of that existing solution I was talking about earlier. We're moving up to about 1,500. The other thing is with that project, we were dealing at that historian level. We're actually going to go a step lower in the stack and actually introduce an IoT field gateway. So we're working with a Microsoft partner to actually provision that device. And then we'll be publishing that event to the cloud. We'll be doing even more calculations with ASA as we pull it out of the Event Hub and actually get more into the analytics. We've been taking that even further for us. So that project's underway. It's early, but October coming up, we've got a bunch of key milestones that we're targeting.
In a solution like that, have you guys thought about whether you'd use Event Hubs or IoT Hub?
It depends on I guess the nature of the publisher, in my mind. Like, so for us, we are not in that command and control space. Certainly not yet. It's way too early. That we need to see things kind of mature and make sure we feel good about that. I think it's really around that. Like if you need to manage the device versus if you don't have to manage the device. So if we're still dealing with, say, a data collector that's already going to publish AMQP, then in that case, going the IoT Hub route doesn't really provide us any sort of advantage, and as a result, we can use Event Hub. On the flip side, if we did get more to the device specific and you have the device talking to the cloud, then that's something that would drive you more towards that IoT Hub solution. But I think regardless with the relationship of Event Hubs in that solution, we're not concerned about scale, right? So we know whatever it's labeled on the front, we're not worried about kind of the mechanics underneath the hood.
Gotcha. Yeah, and it's nice to know too that from the back end standpoint, you can
when
you get to the point where you want to do two-way communication, you can always switch that out for IoT hubs.
An ASA doesn't matter. It doesn't. It supports both of those. So
right.
It's good from that perspective.
Okay. Well, awesome. Well, I have a couple more things to cover, and then Kent will be back up here to help answer some questions. So with that, if you guys were curious about how you can actually get started with messaging today, for those of you who download the deck later, there's 2 links here for some getting started tutorials with both messaging and event hubs. And I also wanted to give you a brief overview of what some of our first-class language support is for. So currently we have .NET Framework available for messaging and event hubs. And we have a .NET standard implementation that's currently in development for messaging, but is available in preview for event hubs. What's interesting about .NET standard is now that can be targeted by both the full .NET Framework and .NET Core, that will eventually become our preferred client library to be used. We currently have a fully fledged Java library available in event hubs, and we're in the process of creating that for messaging. And part of the reason why we did that, before you could use a software Apache ProtonJ, but it wasn't as easy of an experience as it needed to be. So we've gone ahead and have developed our own first-class clients that's fully supported by Microsoft. We also have both management and runtime REST APIs available. This is great if you're trying to do messaging from a browser or events and telemetry in the case of event hubs. And we also use the AMQP standard for both of these things. AMQP is an open standard, and if you guys are feeling up to it, you could certainly develop your own library or use other third-party ones that are available. What I was alluding to earlier when I was asking Ken about cost is essentially this same question here. So here's an example of what it would cost to send 1 million messages a day through all of these systems, and this will give you an idea of what your monthly bill would look like. So for event hubs, you have a flat rate of around $11, and then for an additional 31 million events, besides what's included, you spend 86 cents. So it comes out to a grand total of $12. For Service Bus, you also have that $10 flat rate. And then you have 62 million operations. The key point here is that in event hubs, you pay for the ingress event. You don't pay for the egress event. That's because you can process that data multiple times, have multiple streams. Whereas in Service Bus, that's more transactional. So a message goes in, message comes out, and is fully removed from that. So each one of those is an operation. That still comes out to just under $40. So you're just under 50. Now imagine you wanted to do this on your own IaaS VM. You're running RabbitMQ. RabbitMQ is an open source software. You can run this on your own, but with this you wouldn't have support. You can get that through an additional cost as well. So a 4-core VM with 28 gigs of RAM should be able to handle that. That VM alone, $485. And then lastly here, I just wanted to give you guys a little bit of an example of what it looks like to get going with messaging. These are covered in our tutorials, but really it can be pretty easy. You essentially have a queue client. This is C#, by the way. You have a queue client. You create a connection with that queue client from the connection string and the queue name. Then you have a message body, brokered message, and then nowadays it's best practice to do things via async. So we await that call with send async on the queue client and the body of the message. Event hubs isn't very much different. The only piece that is worth noting is that we expect a byte array instead of the raw string itself. So really it's not too complicated, and it's pretty darn easy to get started. So with that, I'd like to open it back up to questions, and I'll have Ken up on stage here if you guys want to ask either of us anything. I also want to point out as well, if I get through these guys, please evaluate the session and let us know what you guys thought.
The scenarios assume 100% network uptime. What happens in the talk? Has there been an incident where a plant goes offline and then the messages will go through? What exactly happened?
So we've seen not the entire plant go offline. We haven't seen that, but we see that, say, a few devices that may not report. And in that case, we would go ahead and do that backfill request.
Oh, sorry, connectivity to the internet, to Azure in general.
So, okay, Yeah, so I guess this, with the existing solution itself, what's happening is within the power plants, you're typically going to have multi-level networks, right? So you're going to have the SCADA system running on an op LAN, then you're going to have a network on top of that, then you usually have some level of data collection that's basically bridging those two environments. So our field devices are never talking directly to the internet, and that was kind of along the lines of my comment that says, hey, we're not in that command and control business at this point, and I think it'll take a long time for us to do it. So with our existing project, we're actually more, because we're dealing with at the historian layer, we're typically within a corporate environment. So from that publisher, we're in that corporate environment. Now, the next project that we're going after, we will be one level below. We won't be in that op LAN, but we'll probably be in that network one above it. And even there, it would still be a level of data aggregation that would occur between the SCADA system and the data collector. So we would still be sitting on top of that technology.
Awesome. Anything else you guys want to know? All right, otherwise I think we'll let you guys go early then. And Ken and I will stick around if you guys want to come up. Thank you for your time.